You know, there's this whole narrative out there about AI being a bubble. The MIT study that 95% of enterprise deployments don't work. You are the 5% making them work.
We aim at problems that are fairly high value. So like generally we'll aim at problems that are going to be saving customers or generating customers to the tune of like, tens of millions to sometimes the low billions in terms of value.
My former boss, Shyam Shankar, used to say at Altimeter, the job of a forward deployed engineer is to eat pain and excrete product. Sounds like you've successfully excreted some product here.
Yeah.
A
lot of pain.
That's what it is.
That's right.
Today I'm joined by Colin Jarvis, Head of Forward Deployed Engineering at OpenAI. Colin, thanks for doing it.
Yeah, thanks for having me.
I'm so thrilled to be doing this with you. You are actually somebody, I was talking to you a little bit. You joined in November 2022, the month of ChatGPT.
Back in the day?
Back in the day. I think OpenAI was like less than 200 people back in the day.
Yeah, something like that. Yeah, I think I was like one of 2 or 3 people in Europe. Yeah,
wow.
When I started.
Yeah, wow. Well, I'm so thrilled to do this, for a couple of reasons. One, I started my own career as a forward deployed engineer at Palantir about a decade ago.
Super cool.
And second, there's this whole narrative out there about AI being a bubble. The MIT study that 95% of enterprise deployments don't work. You are the 5% making them work.
that is certainly what we say in-house. Yeah, definitely. Yeah. We've been working with enterprises for a while. So
maybe it starts from the start, the origin story of forward deployed engineering at OpenAI. How did you guys come up with this? What was the motivation?
Yeah.
Take us back.
Totally. Yeah, definitely. And like when it started in 2022, I think it was like, ChatGPT came out, there was tons of hype and people were really excited, but it was also like kind of hard to get value from the models at that point. Like people, I think copywriting was like the big use case. Just like you could write papers kind of with it. And I think like what we were excited about with forward deployed engineering is like over those couple of years following ChatGPT, we were able to get customers in production, but it was pretty inconsistent and it took a ton of time every time. And the thing that was like consistently successful in getting those folks to production was just sort of embedding with them, understanding their domain really deeply, and like sitting with the users on the ground and getting them to properly like adopt the technology. And I think we sort of found like our previous hands-off like technical support model was just not reliably getting these folks to production. And that kind of led to us deciding to set up a forward deployed model so that we could, I guess, repeatedly get these enterprises to production.
Makes a ton of sense. And maybe double clicking, what does forward deployed engineering actually do?
It would maybe help if I'll kind of ground this in an example. So one of like the customer examples that like led us to want to set up a forward deployed practice was Morgan Stanley, who we deployed in 2023. They were in fact our like first enterprise customer to deploy with GPT-4. And the use case for them was that they wanted to take their wealth management practice. And this is kind of a consistent feature that we see with people who are successful deploying Gen AI is like they don't do like a kind of edge case like over to the side of the company. They pick something with genuinely high stakes. In this case, Morgan Stanley wealth management is like they're kind of one of the biggest parts of their business. And what we were trying to do was put like their research in the hands of all of the wealth advisors, so that all of them would kind of, I guess, have like more easy access and be able to give like more actionable insights to their customers. And so what we did was I guess the problems to be solved were twofold. At that stage, like RAG was not a thing yet. It was kind of like we have a bunch of research reports. We need to get those in the hands of the wealth advisors, and we need them to trust them. So what we did was we embedded with Morgan Stanley. We worked with their engineers. We first of all did a bunch of like retrieval tuning to get to the point where we could kind of trust the outputs of the research reports. And then we ran a bunch of pilots, getting the wealth advisors to kind of label data, and eventually got them to the point where they kind of trusted the insights and started actually like using them to give to their customers. And I think that's like the kind of key thing with them is like the main technical hurdle was probably solved within like 6 to 8 weeks, but it took a further like 4 months of like doing pilots, collecting evals, and iterating to get to the point where the advisors actually trusted it to kind of put it in, to like actually use it in anger. But the outcome was really good. Like I think in the end, about like 98% of them adopted it. It resulted in like a 3x increase in the amount of like usage of their research reports. So
wow, 6 months to effectively build trust.
Yeah.
But the original product was working within a couple of weeks, as you said.
Yeah. I'd say like probably like within like 6 to 8 weeks, we had the pipeline, we had some guardrails, we had like, we had the retreat, we tuned the search enough that we got like getting decent results. But it's kind of like, it's almost like how good is good enough for production with these enterprises, and especially Morgan Stanley working in a regulated environment. Like there's a very high, I guess, need for accuracy, but also this is a probabilistic technology. Like you do just have to like build the right kind of framework, and then also just like get the users to kind of trust it and give them the tools to verify it where they don't. So,
So that was 2023.
Yeah.
Fast forward to today, 2.5, 3 years in, forward deployed engineering is a hot topic. Probably the hardest job to hire for. There's startups across the spectrum, from AI native startups like Sierra to infrastructure businesses like Baystand to even business and financial services like Ramp. They have forward deployed engineering teams. Really wide range. It means a lot of different things to different people, different use cases. But maybe we can start with a use case where forward deployed engineering has been particularly useful.
Yeah.
Take us deep on an example or two where you have moved the needle and delivered like tangible ROI.
Totally. Yeah. Happy to take you through. So probably like one of our biggest projects right now is with a semiconductor company in Europe. And what we're doing there is like, I guess, like going back to the theme with Morgan Stanley, it's like you got to pick a big kind of problem to solve. And in this case, they basically said like, look across our entire value chain, and we want you to just like effectively take the biggest areas of like waste in that chain and then make them more efficient with AI. And like they basically left it fully open with us as to what we could do. And we basically embedded on site, spent like a couple of weeks just like understanding their business in a lot of detail and looking across their value chain. There's like the design process, the verification process, and the like measuring performance once you've actually shipped these like chip designs. And the one that we really dove on was verification, which is like, again, I guess like the thing that the engineers don't like doing, but probably they have to spend like 70-80% of their time, like, just like fixing bugs, like maintaining compatibility with old versions of chips, all this kind of stuff. Yeah. So what we did was we delivered like 10 different FDE use cases across their value chain with the aim of eventually delivering like I think the total figure that we're aiming for is like a 50% increase efficiency saving and what the engineer's time. And currently where we're sitting is about 20 to 30% for the first couple divisions that we rolled out with. And like if I give you an example of some of the things we do, like one of them is that they have so many tests to run on these chips that they have to like schedule a bunch of them and run them overnight. Every night. And when they come in the morning, every engineer sort of has like something between like a few hundred bugs, which have not come into these tests. And they're just sitting like looking at them like, oh my God, like I have so much stuff to do. And already I just have to like start debugging and work from almost nothing. So what we did was we actually took Codex to start with. And then we started to build on Codex to sort of like tailor it for their domain. And what we did was start off where the model would just like take the bug, go and do a bunch of investigation and then write a ticket for the engineer to say, like, this is probably what's wrong. And when we got to the point where they trusted the results, we then started to actually have the model like go and like actually try and fix it and then raise a PR. And when we did that, we discovered actually we need to like give the model an execution environment so it can test its code. And it's sort of this iterative process where like we started off with just like, this is a painful thing. Let's just like help it be advisory. And what we ended up with was this like what we call the debug investigation and triage agent, which basically goes in and tries to fix like a significant proportion of these bugs. So that when the engineer comes in the morning, our like vision, hopefully by like, mid next year, is that the engineer will come in and most of them will be fixed. The hardest ones will be clearly documented. They'll be able to just go and do them. And like the impact of the engineers, sometimes it would take them like 4 to 6 weeks to actually get through these because they'd be trying to do their work while going and like, swivel desking between fixing bugs, going and writing new code. And now what we're hoping is we can get them to a world where they're just like constantly just writing new code. And as the model is like doing a lot of the supporting.
Bug fixing. Yeah.
This is it.
Wow. This is an interesting tango with the model and your team. Yeah. Where does the model and your team take over? And is that line moving over time?
This is a great question. Like I think ideally you would just go in and you would just say like, hey, here are the tools. Yeah. Like here are the tools I have as an engineer, and here's the problem, and just go fix it. Yeah. And I think that's maybe a world we eventually get to. Yeah. I think what we find is like the first thing we did was fork Codex and add a whole bunch of telemetry so that we could build like really detailed evals. We could be like, okay, if I as an engineer was going to fix this thing, there's a detailed trajectory I would follow of like, maybe 20 different actions where I'm checking different like logs and saying like whether or not there's a problem. And our first step is kind of like figuring out, okay, making like a set of 5 with the experts from the customer and making this like this labeled set and then starting to work from there, because I kind of feel like taking a step back, it's like, even if you do have this perfect future where the AI is able to go away and do these things autonomously, you're going to want some sort of like ability to check its work.
Right.
And so we build this, like, I guess this like kind of eval framework as like a starting point. We call it like eval driven development, but like effectively a bit of LLM written code is like not done until you have a set of evals that verify the efficacy. And that's sort of where we start with this. So I think, coming back to your original question, it's like, if the models get better, hopefully we just run that eval set. It works out of the bars. In practice, the FDEs then have to add a whole bunch of scaffolding around that to then make sure that, like, okay, these bits need to be deterministic. These bits, we actually have a different simulator. We're just going to execute as a tool and get the results. So it's generally like a bit of a kind of like a bit of a mix of the two approaches.
Super helpful. So that's your coordination with the model side. And then I'll ask you another one on the product side. The big pushback, and sorry to use the C word, is that FDs are just consultants.
Yeah.
But is it true that you guys are actually building products?
Yeah.
And if so, where's the line between products that are reusable for other customers and custom work or consulting work that you might do for one customer?
Even in that like brief example there's sort of an element of product where like we're kind of figuring out, okay, is this eventually going to be a PR back to Codex that's going to just like make it better at doing these enterprise use cases? Is there a different product which is different from Codex which is going to solve this problem? But I think maybe a better example is comes from all the way back in 2023, which was another one of our customers was Klarna, and I worked with them.
Of course, very vocal customer.
Yeah, exactly. And I worked with them for a while to do a bunch of things, but the first thing we shipped with them was this customer service application.
Right.
And what we found was effectively customer service was very hard to scale. Like if you're manually writing a prompt for every single policy and you've got 400 policies, this is not a scalable method of approaching this. So we worked out a way of parameterizing the instructions and tools and then wrapping each like intent with a set of evals so that we could scale from like say 20 policies all the way up to 400 policies or more. And this like method worked pretty well at Klarna. What we then decided was actually we were going to like kind of we were going to take this and boil it into like an open source framework that we would use internally, which we called Swarm. And we eventually open sourced that, and the market reaction was actually like fairly good. And in parallel with that, what we did was we started an engagement with T-Mobile, which was, I would say, like even more complex, like maybe 10x more complex in terms of like volume and the number of policies and the complexity of policies as Klarna. But what we found was that this framework actually worked like pretty well there with a few extensions. And so what we did was we then worked with our product team, and we were kind of like, hey, look, we've got some production customers. It's like these primitives are working. Like this like Swarm thing is actually getting like a lot of stars on GitHub, which is like actually has quite a lot of influence internally. And we eventually decided to work with product to stand up a team to build what became the Agent SDKs. And I think recently you might have seen that we released Agent Kit, which is a kind of a visual builder type thing. But that is actually just like a continuation of that story that started in 2023, which is like, let's make a way to parameterize instructions and tools. Let's make a framework, which then makes it much simpler to roll out. And now let's make it easier to adopt that framework through something like Agent Kit. So, and that all sort of came, I guess, originally from, that was a solution architect engagement, but very much an FDE style of delivery. And today the FDEs all use it as like a standard tool in their toolbox.
Wow. So what started with Klarna grew with T-Mobile, now Agent Kit.
Yep.
That's fascinating. So a real product. That's actually out there, built by the forward deployed engineering team.
Exactly.
My former boss, Shyam Shankar, used to say at Palantir, the job of a forward deployed engineer is to eat pain and excrete product. Sounds like you've successfully excreted some product here.
A lot of pain.
That's what it is. That's right. That's right. Well, maybe, this is actually a great example. So while you were ingesting all that pain, maybe tell us a little bit about the before and after of, if I was now on the other side, a customer or an enterprise that had the good fortune of working with you, what does my before and after look like? How am I different before you showed up and after your engagement?
I'd say there's kind of two things. There's there's the problem we're solving. So like there's going to be a whole bunch of like demonstrable ROI. You're going to have like a piece of software which you didn't have before. It's going to solve.
Oh, interesting.
It's going to have it's going to solve your problem.
Yeah.
And generally we work with customers where we'll either have like a set of engineers on the other side that we're going to like hand over to, or we work alongside maybe a partner who's going to then take that forward and operate it, because we see our FDE team very much as like a 0 to 1 team. Like we're going to come in, break the back of like the like difficult novel problems that are at the root of what you want to do, but but then we want to move on to kind of the next problem, and we don't want to sort of be there in the long term. So that's generally the model. I think like apart from the software and the ROI that they're kind of getting out of that software, there's also like a bit of like an understanding of like the FDE sort of ethos and like the way that we deliver, which is they should know like the way you develop with LLMs is like you orchestrate whatever your end-to-end workflow is, you wrap evals around it, you put guardrails to protect the things that you can't really control that are going to happen at runtime, and then you basically just build up an eval set and then test the consistency of this application, and you learn how to like make applications you can trust. And what we hope is that you like don't really need the FDEs to come back once we've sort of solved this initial problem. Although in practice, what we've seen with some of the bigger ones is actually those building blocks, like for the semiconductor example I mentioned earlier. Those building blocks start to actually become an application in their own right, and maybe we start to actually just keep building on top of the foundations. But the like preferred method is that we find a hard problem, we solve a hard problem, and then we extract the learnings and we move on to the next customer.
Fascinating. Is there like a product that you can show us that you've left behind?
Yeah, definitely. Yeah, I've actually got one here that we did for a customer in the manufacturing sector in APAC.
Let's see it. Yeah, let's do it.
Happy to see it. Yeah.
Nothing more than better than a live demo.
Yeah, for sure. Yeah. Let's take you through. Cool. So this dashboard here, just to explain what you're looking for. So this was for a customer in APAC who worked in the automotive industry, and this is a kind of a toy version of what we produced for them. But their problem was that they had an extremely complex supply chain. So if anything happened that was going to affect the like supply of parts, they would need to communicate through all these different teams in terms of like the manufacturing division, then the logistics team in terms of how they were going to like where they were going to get those parts and then move them to the factories where they were actually gonna build everything. So there was like I guess the coordination of this was all done manually by like teams sort of calling each other on the phone. And what we tried to do with them was build like a data layer to start with that create like we didn't move the data, but we just created a couple of APIs so that we could then put an LLM in as an orchestrator that could then like effectively query that data and start to produce like an initial stab at the insights that would have taken you hours or days of wrangling of these different teams. And so like the use case I'm going to go with here is that we have a customer who has just heard that there's a 25% tariff on goods coming from China to South Korea. And normally this would require like coordination across these teams. They would have to figure out which parts it affects, how that affects their supply chain. And then they would have to run a bunch of simulations to figure out like what is the right way to reroute our supply chain to get around this problem. And in this case, what we're going to do is use an LLM to deal with this problem. And the problem with this is that there's a huge number of variables. And as we're like familiar with LLMs, it's a probabilistic technology. There's a lot of like, if you give it full openness to just do whatever it wants, then we're probably not going to trust the results. So we're also going to build in some deterministic guardrails so that we can verify that like whatever plan the model is coming up with, we can always verify deterministically, make sure the numbers add up before we actually go and make any like genuine business decisions. So what we created for them was this off spew here. So whichever plan we're going to make with our supply chain, there's a bunch of like deterministic constraints that are going to be tested here. Like for example, we always need minimum 2 suppliers for tires that we're not going to get stuck. From this perspective, a few on lead time, a few on like whichever suppliers we're using, we need to have all materials covered. All these sorts of things. These are things that you want to be done like 100% of the time. You don't want to trust the LLM to enforce those rules. You want to do those deterministically. And that's kind of like I guess a consistent feature of how we approach things in the FDE team is always trading off like whenever you can use determinism, do it, and then use LLMs for what they're best at, which is like using this probabilistic approach where there's some kind of like nuance required as to what you need to do. So let's play out this scenario. So I'm going to put in what's the impact of a 25% tariff from China to South Korea. And there's a couple of controls we built in here because the customer was quite conservative and did not trust LLMs very much when we started. So we added in a step where it would always explain its reasoning to start with. Again, these are fairly basic, but I'm just like showing you all the kind of different layers that we provide. And we also provided it a bunch of widgets so that it could kind of like display, just display things clearly. Like for example, here's the tariff, here's the impact on the different parts. We also often folks would still not trust it. So we also added other like kind of deterministic checks, like it could just expose tables that you could check its work if you wanted. So in this case, if I wanted to check that those values that it applied for the tariffs are correct, I could pop up this detailed modal. You can see here that indeed all of the parts that originate from China now have a tariff applied to them of the percentage that I asked. So you can also, if we want to look at like a map view, so we'll show you, okay, yeah, the tariffs are hitting this factory, that's producing these parts, whatever this is. Cool. So this is like the first part, is just like this like business intelligence previously required a bunch of like different BI teams to go in, write SQL queries. Now I've got a model just doing all this and kind of like democratizing access to those. But the real value is that then you have to do a bunch of like complex simulations to be like, right, you know, what is the right combination of factories that is going to like minimize my lead time, minimize my cost, balance off all these trade-offs. And equally, that is something that you don't want to ask an LLM to do just like out of the blue. But what we did was we gave it access to a simulator where it could basically play with the parameters that an educated business user would play with, and then we would get it to use those to kind of to basically run a bunch of simulations and then decide what the best one is. And in this case, I'll just I'll like set it off here because it'll execute a few, so it'll actually take a couple seconds. This is like kind of again a toy example, so it's going to do 5 different optimization runs. But in practice, this is actually another area where we've seen folks recently use like agentic sort of approaches pretty successfully. Is effectively getting them to run like, you know, hundreds or thousands of simulations offline and then come back to you with like a well-documented approach as to why this is like the right set of trade-offs that you can do. So once this is done, it's going to come back with a little table here just showing like of those 5 runs, here's the trade-offs, here's the best one based on what you asked me to do. And then we'll pick one, we'll ship that, and then we're kind of good to go.
Fascinating.
Yeah. Oh, here we go. Yeah, there they are. So we can see the different costs and lead times that we've come back with, and the model's suggesting one. So again, I'm just gonna accept plan is final. And you can see here as well, the new plan that's come back, we can see that it's passed our deterministic checks. So we're comfortable. We can also see that the tariff has been applied here. So we can confirm that. And we can also use the map to just like visually see that actually there's a difference. So we're now using a Taiwanese factory where previously a bunch of things were coming from China. So that's just a quick demo of like one of the things that we built for a customer. Again, we've kind of simplified a lot of the details to make this kind of like easily consumable for this. But each of the like aspects under here are things that we've genuinely delivered for folks like both in the manufacturing industry and in others. And maybe that's just I hope that's super. I hope that's illustrative of the sort of thing that we're building. Yeah.
Well, that's a very involved engagement clearly with this one partner, and you know the median public software company earns maybe hundreds of thousands of dollars per customer. Palantir is probably the highest end of that, earns about $5-6 million median ACV per customer. This feels very involved. So like, what is the median size of the prize for your team to get involved? I can't imagine that being a low number.
This is an interesting one. I think at OpenAI, like we definitely don't see the FDE function being a function that is going to be like a cast of thousands. Like we definitely want to be very focusing on problems that we think are likely to be like generalizable and turn into platform in future, or are going to push our research in a new direction. So I think we aim at problems that are fairly high value. So like generally we'll aim at problems that are going to be saving customers or generating customers to the tune of like, you know, tens of millions, sometimes the low billions in terms of value, so that we can ensure that like if we're going to solve this, it's going to have like a big kind of economic impact at the end.
This is the SWAT team.
Yeah. Well, yeah. In a way of saying it. Yeah.
How big is the forward deployed engineering team at OpenAI?
Yeah. So when we started at the start of the year, it was just myself and my colleague Arno in Paris. Okay. We did our first engagement with John Deere with just the two of us, and primarily him. And then we're now 39, and we're going to be 52 by the end of the year. So.
252 in a year.
Yeah, so it's been a quick meteoric rise for the team.
All right, let's go. Wow, you guys are going fast.
Yeah,
there's a lot of. This explains it. I mean, there's not a lot of FDs out there. There's a lot of our, I see founders and CEOs and honestly customers wanting to build forward deployed engineering motion. They're trying to understand, hey, what are the economics of it? What is the right set of my customers where I should deploy forward deployed engineers?
Yep.
What advice would you have for startup founders and CEOs in the age of AI, of like where or how and where to deploy FDEs?
The first thing is to be very clear as to like what your FDE team is going to accomplish. Like, are you going to be determined? Are you going to be relying on the services revenue as like a key revenue stream? Because that is, I think, a very different motion than what we're trying to do here, which is like we're almost like betting on the increase in revenue that we're going to get from like successful product bets that are going to come out of these FDE engagements. And I think that's probably the key thing. I think people try and do both, and then inevitably, I think like from working in consulting in the past, like I always saw a failure mode in those consulting firms where they had a vision of like we're eventually going to be a product company, but unfortunately the like short term lure of services revenue just starts to drag everyone in that direction, and then suddenly you kind of lose like the strategic view. I think at OpenAI we're sort of lucky because we're at our heart we're a research company, and then we became a product company, and those two like that allows us to be strategic in terms of prioritizing those customers. So I think coming back to your question of like what the advice would be, it would be like be very clear as to like what the purpose of this FDE team is, and then fully like push it towards that, and be prepared to say no at some very difficult times, like when somebody's going to offer you a lot of money to do something that's not strategic, and you have to be like you have to sort of hold firm with that.
And the thing that you've got to hold firm with specifically is that you've got to produce a product or a platform at the end of it.
Yeah.
That's right.
Yeah, and I think that is where at OpenAI it's sort of like there's a bit of a trade-off there. Like I'll like sort of break my own rule a little bit there, because there's kind of like there's two things. It's like there's sometimes very economically valuable problems. We're not sure if that's going to lead to platform, but we're kind of like, you know what? That's like such a valuable problem that we're pretty sure there's at least some research learnings here that like if the model were better at this sort of problem solving, like that would be a net good for OpenAI. So let's prioritize that customer. And we actually sort of split our capacity in the team by those two levers. So some of them we have like definite product hypotheses, and we're like looking for like the perfect design partner, the perfect person to build a customer service thing, or the perfect person to build a clinical trial, like sort of doc authoring solution with. Whereas on the other hand, we also have just like sort of industries which have interesting problems like semiconductors or maybe life sciences. And for those, we're more just kind of looking for the right partners who have these big problems that they want to solve. And we split the team according to those two axes. Yeah.
Fascinating. And just to follow up, so as you are creating all this product for these customers, will OpenAI release these products for other long-tail customers where maybe your team's not involved? Should we expect to see like an OpenAI product in customer service or life sciences and semiconductors and so on?
Without giving away too many details, I think it's an option that we're kind of open to. Like we're looking for like additional monetization options in the future. And I think that what I definitely would say is like the FDE team is a 0 to 1 team. Like the way that I would almost see it is like on this product side, we want to prove the product hypothesis. We then want to do it maybe 2 or 3 more times. So if the first thing was maybe like 20% reusable, the next 2 get us to maybe 50% reusable. And then we almost want to like push it into the scaled part of the business and try and do this thing like a whole bunch of times across the market. So that is definitely a motion that we want to build with this team. Although I would say, like, to contextualize, we're like very much at the start of that journey. We have a bunch of hypotheses. We're like trying to figure out where our bets are gonna go. And that's kind of where we're at right now. That's on the like product bet side. If I go back to this like more researchy bets of like trying to solve these big industry problems, I'd say we're considering on that front how we would do this, but I'd say we're less likely to like go into a vertical and have like a vertical specific product that we support as something through the FDE team. But we do hope that by solving these very valuable problems, some kind of like horizontal platform that is useful might like fall out of them. So we're open to that option, but I think it's more on this like product side that we're looking for the reusability.
Super helpful. So 0 to 1. Maybe another 1 to 2 to get it up to like 50%, 60% is good.
Yeah.
And then spread it out to the rest of the world.
Yes, exactly.
That makes sense. Maybe one question on what not to do. You've seen this enough times where I'm sure you've seen a good set of examples where it did not lead to a product or did not lead to learnings. Was there a common thread across those experiences of like, hey, these are things to not do? In forward deployed engineering.
This is why, I mean, we've made plenty of mistakes over the last year, but I think one of the biggest ones is probably generalizing too early. Like I think there's been some cases, whereas OpenAI, like because we have ChatGPT, there's like some functions where you just look at them as like a feature in ChatGPT and you're like, that would make a great generalizable solution for enterprises. And you kind of like go looking for a problem for them. And what we found in a lot of cases is like we then don't do the 0 to 1. We're just trying to like deploy this generalized thing, and it just like doesn't really work. Like I feel like generally in the LLM ecosystem, there's too many like high concept solutions out there that don't really have like a clear problem that they solve. Whereas conversely, whenever we've just gone super deep on the customer's problem and just been like, we're just going to solve this problem, almost every time there's been some kind of generalizable thing that's popped at the end. So I think definitely generalizing too early is like the kind of, I guess, the biggest mistake that we've like made and then learned from this year.
Right. I can't remember. I think it was Paul Graham who said that don't worry about scaling too early.
Yeah.
You'll fix the specific problem.
Yeah. I think doing what doesn't scale is like one of like the sort of like the watchwords of the team, I think, in terms of how we try to approach things. So,
That makes sense. That makes sense. I have a set of rapid fire questions for you.
Yep.
We'll launch into them. My favorite one, which is the long short game, which we love at Altimeter.
Yep.
Pick an idea, a startup, a business that you think is going to benefit and is underappreciated.
Yep.
And the same thing on the other side, an idea or a business that you think is more sizzle than steak.
This is a fun one. So I've got I think starting off with the things I'm long on.
Yeah.
So if I look at like where we spend like almost the like majority of our time in FDE getting things to production, it is like creating the translation layer between the data, like the raw data, and then kind of injecting the business logic in some way so that the LLMs can make effective use of that data. And like people like often just start with MCP and they just stick the MCP connectors, but yeah, exactly. Well, exactly. But I think there's almost like I think the thing that we've had to repeatedly do is sort of build almost like a sort of light like logic layer in between the two that the model then uses to make best use. It's like, when would I like take the data warehouse and mix it with like the contents of SharePoint to answer this complex question? And that is, I think the companies that are in this sort of space that are like almost, it's like the metadata translation layer, which interestingly is actually sort of like, an old school concept. It's like you think of the tools like Calibra and stuff where you're just like, you're documenting metadata. But actually now that it's like LLMs making use of it, this kind of thing is actually fairly useful. So that's actually, it's like, I think if the people who can solve that problem, I'm like fairly long on those folks there.
This is not too different from how, where we place a lot of value at Palantir, like the ontology layer is where most of the secret sauce is.
Yeah. And interestingly, I mean, like the problem's definitely not new. It's like the classic problem of like, do we move the data to somewhere where it's easy to use, or do we like build some kind of layer and use it where it is? And that has not changed. I think the thing that has changed is that now you have, instead of people having to like write queries, exactly, LLMs can do it for you. So this is sort of, and like that means like, do you have to move the data at all? Like these are the kind of decisions. I don't know if we have like a final answer there, but I think that's like a really interesting space because it would just save so much time in these FDE type deployments, and also just like democratize access to the data a lot better.
What a great point.
Yeah.
What a great point. Short.
Yeah. So what am I short on? So this, and I'll caveat this by saying that I'm biased because I'm thinking about like, I primarily work with enterprises, and I think the businesses that I'm short on are the ones that if you look across the whole like, what are the steps to get an LLM application to production? Yeah. It's like I've got to orchestrate it. I got to put tracing in. I got to label those things, build evals, and then I need to like stick some guardrails in. Like these are the kind of rough components. Yeah. The companies that do only one part of that chain are the ones that I don't see getting like broad adoption of a lot of these enterprises. And the reason for that, I think, is like it is difficult enough just to get an LLM application, assuming everything was the same tool, getting that to production is hard. Wiring up all these tools and then dealing with all the integration problems as well is just a bridge too far for a lot of the enterprises, and they really want like kind of like one throat to choke with this problem. Right. So these are the sorts of businesses that I think I'm like more short on.
Right. Yeah. Makes sense. Favorite underrated AI tool? ChatGPT.
Yeah, underrated AI too. So definitely like this one's not underrated. I think I think people like this one, but like Codex is definitely the one that like, the first time that I just like turned it on and then I went and like, went into 4 hours of meetings and came back and like something was done. I was like, oh, this is like magic. But I would say the underrated one is the playground, like the OpenAI playground. It's in platform.openai.com, and it's basically like it's as simple as like if somebody
is this the thing that pre-chat GPT? This is where you could chat with like the Da Vinci.
Yeah, but it's still there. It's still there. Yeah. And there's actually like there's a new version. There's like a voice playground that you can use for the real-time API. And just in terms of like, it's basically like you could somebody just stuck like a nice UI over like the API basically, and you could just interact with the API. But the amount of like demos I've done with that like blow people away, like it's actually such a powerful tool for just being like, is this use case even possible? And you can validate it in the playground. Like I'll give one example of like I was trying to figure out whether this browser automation use case would work, and I just like screenshotted the web page, stuck it in the playground, started hitting it, and was like, if it can I with an N of 10 like make this work, and if it's like 7 or 8 times, then like maybe this is going to work in production. It's like it's just such a simple tool, and I think underrated for like just validating, like just doing that quick like sense check people when you're trying to validate a use case.
I'm glad you reminded me of it. That's actually where I had my aha moment. Before ChatGPT, I was out playing with Da Vinci 03, I think.
Yeah.
I remember chatting with them on Playground. I was like, wow.
Yeah.
Chat happened. I was like, well, I told you.
Yeah,
So
totally.
Back to Playground.
Yeah. I mean, it's an underrated tool. It's for sure.
That's right. A lot has happened since you joined, since chat happened.
Yep.
What's your favorite, highlight of your time at OpenAI, and maybe a low light of your time at OpenAI?
Yeah, I mean, my favorite one are like probably the more like actually the thing that I joined OpenAI for was like when DALL-E 2 came out, and I was just like I'm like I'm like a creative person, I try to be creative, like I like tattoos and stuff, it's lots of fun, but I'm like not artistic at all. And I was like, oh, this is super cool. I can like express myself. So we got a chance to do an engagement with Coca-Cola where we did this Create Real Magic campaign where like they were like the first partners to get to use DALL-E 3 before it even came out. And we had to make like a version of DALL-E 3. And we got to like generate all this and it was like the process of tuning this that it made like perfect Christmas imagery with Coca-Cola was like such a sort of like, I mean, it's like sort of like just a fun use case. But I just thought like that is it was sort of like coming full circle from like the thing that brought me in, and then I got to actually like, ship it to all these people around the world who are like using Gen AI for cool stuff. Like I really like that one. It was not the hardest use case, but it was also I mean, there were genuine risks. Like people could have jailbroken it, caused lots of problems with the model. So I mean, it was also satisfying to ship it, but really just like just sort of like a fun use case and like a nice consolidation of like, wow, look how far we've come. It was like from pre-ChatGPT all the way to DALL-E 3. There's that one. And what was the other question? Yeah, the lowlights. So good question. So I think at OpenAI, we go through this like, B2C, B2B sort of like ebb and flow. And like, given that I've always been on the B2B side, I think there's been times, and I think it was maybe like from the first dev day, like we released the assistance API and stuff. And then there was maybe a period until the dev days of the next year where it felt like the company's focus was so much on the B2C side. And I talked about open sourcing Swarm. Like one of the reasons we open sourced Swarm is there was just like not a lot of interest in like this sort of framework, which is like it was viewed as more for like a B2B audience. So I'd say that was maybe like my least favorite time, in that I felt like in that time we shipped like, we shipped Morgan Stanley, we shipped Klarna, like all these super cool like enterprise use cases, but it was just, there just like wasn't the investment from the business. And we kind of felt like we were like, our words were falling on deaf ears until suddenly, towards the end of 2024, suddenly the pendulum swung again. And then it was time to go all in on B2B. And ironically, that was when the FD business case got approved. And then it was like, right, let's go, and it's been good since then.
That's awesome. Well, as you said exactly, ChatGPT was a big story of 23, a big part of 24. Agents, the year of agents. What is 2026 going to be the year of? What's the next big wave, you think? What are we going to be talking about next year?
Yeah, that is a great question. So I can kind of only guess here, but I feel like when people are talking about this year as the year of agents, but I feel even now with agents, it's like there's still a lot of work to like get those things to production. And I feel like if you were to take a step back from agents and like fine tuning and all these techniques, like what you really want is just like LLM application that you just like turn it on and it just sort of learns from your behavior and then it just sort of works. And I wonder whether 2026 is actually going to be the year where we actually go back to like fine tuning models where it's like, we now just like have these agentic networks, we orchestrate them, but now we finally have all the plumbing to like make the training data, label it really quickly, build a training set, fine tune a model for specifically this agentic use case, and then suddenly it's like it just works beautifully. I feel like we're like the building blocks have been getting built this whole time. That's why people can now use agents. Like before, they couldn't even think of doing complex things. Now they can. And I just wonder whether that's going to be like sort of the next frontier where like agents aren't just being used. They're actually being used for very specialist domains where you do need to tune them to be good at like chip design or drug discovery or something. We get to that point where it's like we actually go back to fine tuning models now that we have all of like the plumbing and stuff. So it's maybe like the year of optimization or something, or maybe the year of like one click to production. You know, who knows? But
that's such a good that's a good framing. I was thinking wearables, hardware.
Possible.
The state of hardware leaves so much to be desired.
It does. Yeah.
But well, this was a lot of fun, Colin. Thank you so much. Thanks for telling us all about forward deployed engineering.
Cool. No, thanks for having me.
Awesome.